So in our previous example, we happened to work with kind of nice values, right? Well, in the same example context, right? What if we're looking for the probability that a male's digit ratio is less than, probability that D is less than 1.00, right? Well, okay, if we remember our quick sketch here, right? 0.95 was right in the middle, and then one standard deviation out, that was 0.98, and then I jumped to 1.01. And, well, my value of interest, 1.0 is right there, but I don't know what the probability is based on the empirical rule, okay? And that's where we need to do more work, okay? So you kind of have three options. One, you can just sit there and cry, not going to be helpful. You can do calculus, okay, well, and that's maybe not in our skill set yet, or we can use technology. Okay, so here's kind of the flow chart that I recommend. The technology we're going to use in this course is Microsoft Excel. There's other technologies you can use to help you with this. But then kind of the flow chart or the thought process you need to do is after you are well acquainted with the context. Okay, that's always number one. Okay, and I might even add, you have your picture drawn. Uh, so you've read it, you have a picture, you need to figure out what you're given and what you want. Okay? So if you're given an observed value and you want a probability, then you're going to go one route. If it's flipped, you do the other route. Okay? So here, what I'm given or what I want is a probability, right? And what I'm given is a population value, right? So I'm given that population value and I want a probability. Okay, so I need to write a probability statement. Okay, did that. That was P of, D is less than 1.00. Okay. Okay, and then now, okay, I have a choice. Probability of an event is smaller. Okay, that's my case. That's where I'm at. Okay, but smaller or larger is kind of the deciding factor. Okay, because it's going to tell you which command in Excel you're going to need to use. If you're looking for smaller, right, what Excel will do is it can compute values to the left just with norm.dist. What you actually need to do here is it's sort of the complement rule because what your picture is going to be is you're going to want something like this, but what you'll do is compute this piece in red, and then you remember the complement rule, since it is a probability, you can do 1 minus that, and then you'll get the blue. Okay, so that's why we have to do 1 minus in the other case. Okay, so now revisiting our example, we have, here P of D is less than 1. Okay, so then in Excel, what I will do, and I'll show you this in a moment, I'm going to use norm.dist, and then there will be a command, some syntax in here. You'll see it is the value, so that's going to be the population value. And then it's going to ask me to list the mean, 0.95, and then it's going to ask me the standard deviation, 0.03. Oops, and then we're always going to just insert true after. There's an option to do false, never do false. If I'll explain that in class if you're interested. Okay. I'm going to set up one more, part B. What is the probability that a male's digit ratio is at least 0.88? Well, that's P of D is bigger than 0.88. Okay, so now kind of going back through my flowchart, I'm looking for that larger piece, right? So this is where I need to do the 1 minus. Okay, so I'll do I could do norm.dist, but that's to the left of the value, and then I just need to subtract it from 1. Okay, so 0.88, 0.95, 0.03, not 0.003, and then true. Okay, before going further, let's go into Excel and calculate each of these. Okay, for this, you don't need any sort of special file. You can just use any blank Excel file. So open up Excel and we'll go through and calculate these. Okay, so in Excel, we're going to type equals and then norm.dist for the first one, and then it was less than 1, right? So 1.00 if you want, doesn't much matter. 0.95 for the mean, you can see it's highlighting as I go. Standard deviation was 0.03, and then, oops, and then I forgot to do true. Okay, there we go. So 95%. 0.9522, we'll use that. For the second one with at least 0.88 digit ratio, that would be 1 minus norm.dist, 0.88, 0.95, 0.03, and true. Okay, and I get 0.99. Okay, so now I can go back and put that in my exam or as my answers to my examples. Okay, for the last one, okay, what percent of males have a digit ratio? So I'm looking for percent is a probability. Okay, I just need to change it to a percent at the end. Have a digit ratio that is between 0.91 and 0.99 or 0.7. Okay, so just for reference, okay, we remember that the mean was 0.95, okay, and so I know 0.91 would be out here, and 0.97 would be here, okay, and what I want is this region in here, okay. Now, so far, all I've said is that Excel, we know how to do lower than a value, right? Or we know how to do above a value, okay? So, well, there's many different ways you could do this. You could, if using that idea, you could do like 100% minus the green areas, right? That will work, okay? If you want to do a different route, like I'm going to do, this could work as well, okay? What you could do, maybe let me erase some things here. Oops, undo that. Okay, there we go. Okay, so what I'm going to do is I'm going to calculate the area to the left of 0.97, so that's the yellow area. Okay, I'm going to calculate that. Okay, but then that's overcounting, right? I need to remove this lower part, so then I will remove this lower piece here. Okay, so effectively, what this boils down to is I'm going to calculate probability of the random variable d being less than 0.97, and then subtract probability, of the random variable d being less than 0.91. Okay, so there's two different Excel commands that I will do in one. Norm.dist of 0.97, 0.95, 0.03, and true. That'll give me that first piece. And then I'm going to subtract, close parentheses, norm.dist, 0.91, 0.95, 0.03, and then true. And this will give me that second piece. Okay, so let's hop into Excel and do that. All right, so in Excel, norm.dist, 0.97, 0.95 for the mean, 0.03 for standard deviation, and then true, minus norm.dist, 0.91 now, 0.95 for the mean, 0.03, and true. There we go. So 65%, 65.63%. Okay, so let's capture that result. So as a percent, that would be 65.63%. Okay, and that would be my answer here. I like to include my Excel commands just as evidence of my work as well as the probability statements. But big takeaway here is that if we if we end up with a sketch where, we have a value that is, or we're looking at a value that is not on one of those nice standard deviation lines, we can use this chart. Now you might be wondering, well, we didn't use the right part at all. Stay tuned.